Hello students, in this video let us see the structure design methodology and verification, which are the last two topics in your second unit. So what is a structure design methodology? As the name itself says, it's a design methodology and it is in a structured manner. So what do we call or why do we say so? Because the structure design methodology, or in short you can see it as SDM, it views every software system as having some inputs that are converted into desired outputs by the software system. The software is viewed as the transformation functions, that is, which transforms from one state to another. So here what is the transformation? Actually the given inputs is transformed into desired outputs. Okay, and the problem of designing the software system is considered to be properly designing the transformation functions. So when you are actually developing a software, only your intention in a core manner, you can say it as your intention is only to convert the input to a output. That is, you are only bothered about the transformation that happens between the input and the output. Okay, so there are four major steps in this strategy. The first four are the major ones and the rest are the helping ones for this four. Okay, so the first is restate the problem as a data flow diagram. So what you do, whatever the problem you have, when you are designing a software or you're trying to build a software, what you do, you actually convert whatever the client has come up with the problem, you convert into a statement. Okay, so what in this situation, what you're trying to do, you're trying to state that problem as in data flow diagram. Okay, you're trying to put the statement in the form of a data flow diagram. Then once you do that, you obviously have this input and output, right? What is the input need to be put and what is the output you accept from the design or the system. Then you do the first level factoring. What is the first level factoring? It's nothing but you are having a design and you are trying to make what is the first thing that has to be done. Okay, that we call it as a first level factoring. That is, you're trying to simplify the whole system into a from where you have to start the system. Okay, so that is the first level factoring. What is the first thing you need to do with the system or to build a system? So then after doing that, what you do, you factor the input, output and transform the branches. This is what need to be done. This is what is need to be done. When you do these things, what are the things that are you need to keep in mind? Is the next one for that is the design heuristics. That is, see, we have given the four major steps. Okay, and you build your system with the help of those four steps, but it is not compulsory that you build your system as mentioned in the above four steps. What you can do, see, as the situation asks, you can design it in your way. For example, some system may be complicated, so the first level factoring may not be enough. You maybe need to do the second level, third level, and so on. Or it may not need the factoring input, output, and transform branches. You can, if it is a simple software, you can just come up with just a data flow diagram and you can just proceed. So it totally depends on the one who is actually planning or building the software, one who is actually trying to do the software, create the software. It depends on him, what his judgment takes. Okay, so that is one thing. One more thing is the transaction analysis. That is, what is a transaction actually? Here again, the first it was called as a transform analysis. That is, as I told you, from one system to another, whatever the transformation takes place, so that is a transform. So later on it was modified as transaction analysis, because whatever it is happening, that is, the conversion from one state to another, you can say it as from input to output, whatever it is. So trans that transformation, we call it as a transaction, because once one transaction happens, in the next level, next set of transaction happens. Okay, so this you need to know, or this you need to identify, and you need to either split the transforms that are being done, or you need to, analyze whether these transforms are needed. So the main important thing you need to keep in mind during this phase is that, see, the arrow marks entering in a transaction, or a circle, as you have seen in the data flow diagram, they should not be more than some limited count. What happens, you will not know what is going on, like how many arrows are coming in or what they are meant for. Okay, so when you think, you can simplify the diagram or simplify the input arrows, in the sense you can have 2 to 3 modules and you can have the input through those things. Then you need to make it a separate module and introduce the input arrows. Same thing goes for the output also. Even in the output, simply you cannot put all the arrows from one module and say that you get the output. No, what you need to do, again you need to try to simplify the module so that you get so many output modules, and through that you can have the arrows going out of it. Okay, and again that depends on whom, the one who is actually doing it, or one who is actually trying to create a software. Upon his judgment it depends. Okay, and it's a, a thumb rule, or it's like a keynote, that input arrows can be more, it doesn't matter, but the output arrows should not be more than what is a limit, or more than that can be handled. Okay, so these things it's needed to be kept in mind while doing while having this structured design. And see, what is the, after doing all these things, what is the intention of doing this? See, the main thing is that, see, these steps cannot be simply mechanically executed, in the sense you cannot put it into one system and just it cannot come out like that. What is needed? Human intelligence, or human reasoning, or human intervention is needed. Okay, so all design methodologies may be the best, but they are only just a guidelines. Even though they are the best, they are only the guidelines. What we can do, we can take help of these guidelines and design the system. But wherever the however the case may seem, whether it's difficult, whether it's easy, or you can just come up with the ideas easily and you can do it easily, design it easily, then what you need to do, it's you need to actually think of it. You cannot simply design it. So one way to do this is what? Having different modules, and see if see what actually works for this system. You may see, refer an old software and do try to do the same in this. No, you may see it, you may learn from it, but while applying to this software what you are working on now, you need to be cautious, like what actually works for this software, you need to put it into practice or put it into creation. And see, some of the methodologies you have worked for the previous softwares may not work here, right? So what you need to do, even if that is the case, if it has worked for some other softwares, you need to see whether it works for your software or not. If it works, then fine. Then if not, what you need to do, you have to come up with the new things. Example, for example, you have to deal with the inputs, like issues of screens, reading data formats, errors, exceptions, completeness of information, structure of the information. All this may not be used in some softwares, like there may be some simple softwares, but when these things come in your software, you have to be very careful on what you are using or what you are trying to use and do. And one more thing is the DFT. you have to be very careful of the DFT what you are using. And in a DFD there are again, like, either you can come up with the easier one. You need to actually come up with 2 to 3 DFDs and you have to choose the best one. When you do that, what you are meant to do or what you're willing to do in an effective manner will be actually effective. Okay, so these things you need to keep in mind and actually design the software. So that is all about the structure design methodology. Next is the verification. What is verification? Verification is nothing but you're comparing whatever you have done, I mean the developing of the software, you're checking with the requirements that has been given by the customer or the client. That is verification. So what you need to do, you need to prepare a checklist of things, like whatever is there in the requirements, has that been fulfilled or met while designing the system. Okay, so this is done soon after the design phase. Why is so? Because we all know, once a software has been begun or is has been started to do, you cannot make changes very easily. It becomes very difficult to make changes. Some may be easy, but others are not. So, what is your intention or what you mean to do is, in every step, you need to verify whatever the things has been done. For example, even while taking the SRS, the first thing you are actually doing is what? You are actually checking if taken requirements are full. Are they up to the mark? Is the client satisfied? And is it understood by the designer or one who is actually trying to build the software? So that is the first and foremost thing. As soon as you complete, you are actually going to check it again. Then next, when you are actually designing, as soon as the design is complete, you again need to verify whether it is right or not. Anything need to be added, anything need to be subtracted, you need to see that. So what is done? A sample checklist is done. Okay, so some of the few general items that can be used to construct a checklist is given below so that you can do the design review. Okay, so the first is each of the functional requirement taken into account. That is, whether all the requirements, especially the functional ones, are taken into requirement or not. That is, whatever the clients has said, everything, each and everything, has it been put into the design? That is checked first. Next, are there analysis to demonstrate that performance requirements can be met? So, are the requirements met? Are the performance requirements met? What do you mean by performance requirements? The performance, see, simply you build the system and keep it, oh, it's working. No, it doesn't happen that way. That has to work within a set time frame, right? See, if you put an input and if you get an output after half an hour, it doesn't work, right? Even like your software may be working, but it is not the one feasible one. What you need, you just put the input, you should just get the output. Okay, so you will check whether the performance requirements are met. Next, are all assumptions explicitly stated and are they acceptable? That is, are the assumptions what you have made while designing the software, whether it is stated properly, and can those assumptions be accepted? For example, say assumptions are like this. So I'm just giving an example. If you say, let us say there is sun at night, you can't you can assume that, but is it accepted? Can there be sun during night? No, right? So whether those assumptions what you make, are they acceptable? Okay, so that is the thing, that those things you need to keep in mind while designing. Then, are there any limitations or constraints on the design beyond those in the requirements? That is, there are, when creating some software, it's not possible whatever the client asks us to do, right? Sometimes some things may not be possible. For example, some of the readings or some of the uh, measurements you need to do, or some of the weights, for example, if you want to do you cannot simply do the software without the sensors, right? With the help of sensors maybe you can do, but if the client is asking he doesn't need any sensors, does it work that way? No, that's a limitation, right? You cannot do that way. So are there any limitations beyond those that are in the requirements? In requirements there might have been mentioned some of the limitations, but are there anything beyond that? Because when designing only you come to know, okay, these are the things that we need to do and these are the things that cannot be done, so you are going to check that. Then, are external specifications of each module completely specified? That is, any other specification, external specification in each module has been told explicitly or is told or specified, so that the while designing they keep those things in mind. Then, have exceptional conditions been handled? That is, what are exceptions? Actually, it's nothing but what if an user gives a wrong input. Okay, what if the system takes the wrong input? So something, there has to be an output, right? It cannot simply go and get it, just get hung, and user cannot do anything about it. That should not happen. Then what should be done? If at all something goes wrong like that, there has to be an error message or something has to be there, right? So those are the exception handling. Then, are all data formats consistent with the requirements? That is, in the requirements, have they told one format in one part and another format in another part? For example, the best example for this is the date, let us say. See, in one part of the system or in one part of the project, they cannot ask it as the date to be in the month, date, year, and in another form they call for date, month, year. No, there has to be consistent in the formats of data. And it goes the same for like this, like for example, the amount of some grocery items while you are creating a software. See, for example, naming the price of the rice in rupees and naming the price of some other goods in pound or a dollar. It doesn't happen like that. You cannot do it that. There has to be an consistency. Okay, that is the one thing. Next is, are the operator and user interfaces properly addressed? That is, who is actually operating, and what is the username to be given, what are the rights to be given. All these things has been properly addressed or not. This has to be checked. Then, is the design module and does it conform to local standards? See, you do the design, but is it understood by the locals? So you cannot have an like international standard software for a local grocery shop. That doesn't happen that way. He cannot even understand what's going on. For example, maybe some of the items that you've added, or the technology that is being used to calculate that, all those things. So it should always conform with the local standards. Okay, that has to be approved by the local people or the locality or the local government, whatever it is. And, are the sizes of data structure estimated? Are provisions made to guard against overflow? See, this is one of the main thing and the most important thing. See, we simply cannot just design a software and give it to the client. The first and the foremost thing is this one. That is, over a period of time, when some days has crossed, if your data structure cannot hold the information that is given, or the amount of space given for that is not enough, then your whole software goes into waste. So that is the first and foremost thing that it should be calculated. Especially the data structure size has to be estimated, and provision should be made to guard against overflow. If at all the stack overflow happens, then what? So all these things should be handled. So this is all about the verification. Thank you.